should be able to have blocks as big as you want. Like, he repeated all the talking points, and so a lot of people were kind of sucked into that, right? And so he unfortunately was able to basically dominate a big part of the Bitcoin Cash community for a long time. And then eventually, of course, more and more people started to catch on. He would just say technical things that are completely wrong, right? Like, one example of this that I remember is that he mixed up the concept of 256 bits and 2 to the power of 256 bits, right? So, the difference is, it's like the difference between, 80 and the concept of 80-digit numbers, right? And because of this, like, he made this argument that said that Bitcoin's elliptic curve is friendly to cryptographic pairings. Like, you don't have to understand what that is, but if you want to know, I have articles on both at vitalik.ca. But basically, he made this like technical argument that really hinged on this point, and then when people pressed him on it, it's like, yes, what? No, like what? Look, exactly. The height is like what, 2 to the 256 bits. That's a very tiny amount of information. No. 2 to the 256 bits is more than the amount of information in the universe. And like, he equivocated and kind of like preyed on people's inability to understand that mathematical nuance. And I called him out, and eventually I even called him out in person at this conference in Seoul. Like, I just stood up and asked the hey, conference organizer, why are you letting this fraud speak at this conference? Yes. And I remember even some big blockers at the time getting angry at me. But eventually they did get rid of him, and then Craig Wright was forced to split off because the rest of the community refused to accept some network change that he wanted. And so then there was the BCH and BSV. And then in the Bitcoin Cash community, there was this drama of, are they going to add a developer fund where they redirect 12.5% of the revenue from the miners to the devs? And according to the libertarian non-aggression principle, is this technically theft? And,
like, his understanding of the technical depths of cryptocurrency was lacking in a way that Satoshi Nakamoto certainly would not.
Yes, exactly. But the point is that, like, even after Craig Wright got expunged, the Bitcoin Cash community kept having these disagreements, right? And now, after this development funds dispute, there was a further split between Bitcoin Cash and ABC. And so, the branching tree continues to extend, right? So
in that way, it's disappointing to see those kinds of splitting. There was never resolved.
It is. I would have definitely wanted to see more of a kind of like principled coin with that like tries to be Bitcoin, but follows consistent big block values. But I don't know, maybe I should just stop expecting projects that I have no involvement in to care at all about what my values are, and maybe Ethereum just is.
It just is. I think you have a powerful voice, and you can inspire other projects to do to live up to their best possible selves. Okay, so that's the level. That's the layer one approach. The other layer one within Ethereum is the idea of sharding.
Yes. What
the heck is sharding?
Okay.
What does the future of sharding look like?
Right. So to summarize that big, long tangent that we just went
It's a beautiful tangent, by the way.
It's an amazing tangent. And I think crypto is just one of the most underrated aspects of crypto is, I think, how you can analyze the, the sociology and the politics and the anthropology. And and I'm sure Dan Carlin would have fun exploring the space at some point. But the core trade-off, right, is that if you scale blockchains the dumb way, just by increasing the parameters, then eventually you just make it harder and harder to participate as a node, and you end up with a system where there's 20 computers running the whole thing, and it's just very centralized. So sharding basically says, well, instead of just increasing the parameters, what we're going to do is we're going to change the blockchain architecture in such a way that each individual node in the blockchain only needs to store a small portion of the data and only needs to process a small portion of the transactions. So you can think about it as being inspired by BitTorrent, right? On BitTorrent, there's no such thing as a BitTorrent full node that has every movie, right? The work is split up among a huge number of computers, and that makes sense. That's the only sane way to scale a system like that. And if they actually tried making a version of BitTorrent that required full nodes that store every movie, then it would have zero censorship resistance, and it would just be dead in an instant. So the challenge with taking that model and applying it to blockchains, right, is that blockchains aren't just about like spreading data around. They're about agreeing on exactly what data was spread around and ensuring that everything that you agree on actually is correct. And so you have this paradox where, let's say you want to have a system that supports 10,000 transactions a second, but each computer in the network can only personally verify 100 transactions a second. So how can each computer get a guarantee about the other 9,900 without actually going and verifying them themselves?
Yep.
And it turns out that there are some like a bundle of different tricks that can do that, right? So like one of them is just random sampling. So the idea behind random sampling is, like, let's say for simplicity, this is a proof of stake chain, and you have 10,000 validators. Validators are like, the stakers. And like for simplicity, we'll assume they all have the same number of coins, right? If someone has more coins, we'll just kind of split them up and pretend they're 10 stakers. Then you do like some random shuffling, and you basically say these random 100 validators are assigned to validate this block. These random 100 validators are assigned to validate this block. These random 100 validators are assigned to validate this block. And so each individual computer only gets assigned to validate like a small piece. But then the way that the information about like what's valid gets passed around, right, is that when these 100 participants validate a block, they all sign a message basically saying like, yes, we agree that this block is valid. And then like they combine that signature into one, and then they broadcast that signature. And then everyone else, instead of verifying the blocks directly, just verifies that signature, right? And so if I see the signature, I'm not directly convinced that that block is valid, but what I am convinced of is that out of this committee of, or this randomly selected group of 100 validators, let's say at least 70 of them agree that this block is valid. And so if I trust that, the majority of these participants are all honest, then because it's all randomly selected, the attacker can't just like force themselves into one committee. And so, the attacker is going to be evenly spread out too. And so if, the entire set of validators is mostly honest, every committee is going to be mostly honest. And so like bad blocks are not going to go through, right? So that's like one simple form of sharding. There's also other more clever things that you can do. So for example, there's this concept of ZK snarks, right? I'll call it zero knowledge proofs. So this is the idea that you can make a cryptographic proof that says, I verified or I ran some complex computation on this piece of data and I got this answer. And so if you make these kinds of proofs, then like if you see a ZK snark that says some block is valid, then you're convinced that that block is valid. And even if, everyone in that committee is evil, like they have no way of making a valid proof for a bad block. Right? Like, because the proof itself, like it is a proof that you did the computation, where that proof is much easier to verify than just running the computation yourself. And, there's once again, super awesome mathematical cryptographic magic behind making ZK snarks work.
So it gives you a little bit of a leg up over the 51% honest assumption. So it's a little hack that improves upon the random sampling thing.
Exactly. And like there's other hacks, right? Like there is another hack called data availability sampling that allows you to make sure that the data in the blocks was actually published. But like basically, like if you stack a couple of these tricks on top of each other, you can create a system where like I, as an individual participant, can be convinced that everything that's going on in this distributed blockchain thing is correct without actually personally checking more than like a percent of it. So that's sharding.
That's sharding. But as I understand, maybe correct me on this, is in the space of Ethereum, the sharding happens on some fixed number. Like the split is on some fixed number. I think it's 64 is the currently sort of proposed number. So how does that help scaling? Is it just a fixed constant scaling by 64? And is that a way to achieve the crazy amount of scaling that seems to be required to use cryptocurrency for purchasing? So doing like competing with credit cards and Visa and so on.
Right. So first, I think like the 64 can be hard forked up over time. So we've set it so that like there's theoretically space in the data structure for 1,024 shards. It's just that 64 of them are turned on. Like there are challenges with having more shards because like you have to have logic that just like checks and manages all of those shards. And if there's too many of them, then that becomes too expensive. But even still, you can improve quite a bit. And then the other thing that we're doing is if we're getting maximum scalability by combining rollups and sharding. Right. So this might be a good time to talk about rollups.
What are rollups?
Okay.
And now we're moving into layer 2 ideas.
Yes. So the idea behind a rollup is basically that, so instead of just publishing transactions directly on chain and having everyone, do all of the checking of those transactions, what you do is you create a system where users send their transactions to some central party called an aggregator. And theoretically you can have a system where the aggregator switches around, or where anyone can be an aggregator. So, it's still permissionless to send things. Then what the aggregator does is they strip out all of the transaction data that is not relevant to helping people update the state. So when I say the state, this is this is a very important kind of technical term for blockchains. I mean account balances, code, things that are internal memory of smart contracts. So basically everything the blockchain actually has to keep track of and remember, right? So you just put in you take all these transactions, strip out all the data that's not relevant to telling people how to update the state. And then you take the data that's needed to update the state, and then you really compress it, right? So for example, if we say, I, Vitalik, have an account that's 0xAB58 blah, 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 and it's 20 bytes. Well, instead we can say, I have an account that is number 1874224 in the tree. Right. And that goes down from 20 bytes to just an index and a position, which is 3 bytes. Right. So you use all sorts of these fancy compression tricks, and you basically just, instead of publishing all these transactions, you publish this tiny compressed blob. Right. So the amount of data that goes on chain goes down by maybe about a factor of 10. Right. And then the second thing is that you don't do the computation on chain. Instead, you do the computation off chain. And there's one of two ways to do this, right? One is called a ZK rollup, which is you just provide a ZK snark that basically says, hey, look, I did this computation and I have this proof that here's the some hash of the result and it's correct. And then you stick it on chain and everyone verifies this one proof instead of verifying all these transactions. And then the other approach is called an optimistic rollup, which is basically made of this scheme where first, someone says hey, this is what I think the result of applying these transactions is, and then someone else can say, I disagree. The result is different. And only if two people disagree do you actually just publish all of the data and run the whole that whole block on chain. So if there's disagreements, then you just run everything on chain, and whoever was wrong loses a lot of money, right? So disagreements are very rare and they're very expensive. And in a ZK rollup, you don't even rely on this challenging game at all. You just rely on a proof. So the core principle is basically that instead of lots of transactions and everyone verifies every transaction, it is you take the transactions, you strip them down and compress them as much as possible, then stick that on the blockchain. You do need to stick something on the blockchain just so that everyone else can keep up to date with the state, so they know what all the contracts are, what all the balances are, and all of this. But it's a very small amount of data, and then you use one of these other off-chain games. Could be this optimistic game, could be a ZK snark, to just prove that somebody out there did the computation and the result is correct. Right? So you're pushing 90% of the work off-chain, and then 90% of the data and 99% of the computation off-chain, and then you still have 10% of the data and 1% of the computation on-chain, and so your scalability goes up by a factor of about 100. So these systems are already live for some applications, right? So there's something called loopering, which is just a ZK rollup for payments, right? So you can have assets inside of the loopering system, and you can go around and transfer them, but and you get much lower transaction fees, right? Instead of $5, you'd have to pay less than 5 cents. But the only problem is that this only supports a couple of applications right now. Making one that supports anything that you can do on Ethereum just takes a bit more work, but that's being done as well, right? So within a few months, I'm expecting fully Ethereum capable rollups to be available as well. So rollups, just summarizing, do most of the work off chain, put only a little bit on chain, factor of 100 scaling, sharding, another factor of 100 scaling, 100 times 100 factor of 10,000, hundreds of thousands of transactions a second, and there's your scalability.
Okay, so you achieve scalability, you can do a large number of transactions very quickly, and the cost of doing those transactions is much lower. You wrote that in the long term, ZK rollups are going to win in terms of layer 2 technology. Specifically, you wrote, in general, my own view is that in the short term, optimistic rollups, as you were saying, are likely to win out of general purpose EVM computation, and ZK rollups are likely to win out for simple payments, exchange and other application specific use cases, just as you were saying. But in the medium to long term, ZK rollups will win out in all use cases as ZK snark technology improves. Why do you think ZK rollups are going to win the big picture battle over layer 2 technologies?
So I think ZK rollups, once you accept that the technology works, are just conceptually simpler and they have nicer properties. The reason is that they do not have this concept of a challenge game, right? As I mentioned, in an optimistic rollup, the way that you ensure that the results are correct is that you let one person submit, and they just submit with no proof. They just say, here's what I think the result is. And then if someone else disagrees, they make their own submission. And then if you have two disagreeing submissions, then you actually publish it on chain and you see who's right. But for this to work, you need to actually wait for someone to disagree, right? So for example, if I have an asset inside of an optimistic rollup and I want to withdraw it, then I actually have to wait a week to withdraw it, because if a block that contains my withdrawal turned out to be invalid, then there needs to be space for someone to disagree with it, right? Whereas with a ZK rollup, you don't need time for disagreement because you just have a proof, right? As soon as a block is submitted, there's a proof, and it's correct.
So if disagreements, especially in the long term, are sparse, then you don't want to do the optimistic, the game theoretic thing. You want to do the ZK snark.
Right. The ZK stuff is just you can, in a ZK rollup, you can withdraw immediately. You don't have to worry about the economics of proving as much. Right? There's just fewer issues. The reason why ZK rollups are not winning everywhere today is because ZK snarks is still a crazy new technology, right? This is something that 10 years ago, it existed only in theory and there was none in practice. Then 8 years ago, people were just getting excited about it in Bitcoin conferences for the first time. Starting 4 years ago, or 3.5 years ago even, that was the first time you were able to make any ZK snark based anything on Ethereum. And then people started making them, and ZK technology has only really become efficient enough to do a lot of things within the past maybe 1.5 years. So it's new technology, it's crazy technology, it's admittedly scary technology. If you want to learn more, I also have an article about this on Vitalik.ca.
It's actually really, really good. Most of your writing, it's technical, but it's accessible. I highly, highly recommend to check out Vitalik's articles and blogs, whatever you call them.
Yeah,
on the website. It's brilliant summary of the work. Actually, Ethereum documentation period is really good. I think that's somewhat crowdsourced. That documentation is really, really accessible and brilliant. But let me ask about sort of other approaches to layer 2, like side chains. So the one popular one is Polygon. What are your thoughts about Polygon, which is a layer 2 network? Is it positive? Is it negative for Ethereum? Is it both? Does it have a future, which is its own chain, but it's using Ethereum? It's based on Ethereum essentially. Or maybe you can describe what it is.
Yeah. So I think there's a really big and important difference in security models between rollups and sidechains, which is basically that rollups inherit from the security of Ethereum, right? Yes. So if I have coins inside of Loopring or Optimism or Arbitrum or ZK Sync, then even if everyone else in the world who is participating in these ecosystems hates me and wants to steal my money, I can still personally make sure that no matter what happens, I get my money out. It might be a bit expensive for me to get my money out, and I have to do transactions on the main chain, but I'll be able to do it. Whereas in Polygon, which is a sidechain, and so instead of being secured by Ethereum, it's also in part secured by its own proof of stake consensus with its own token. So if 70% of the whole, or even 51% of the holders of Polygon tokens wanted to take my money in Polygon, they can, right? Mm-hmm. So that's and like, to be fair, like there aren't even like the supply, I don't think, is even that widely distributed, right? So like potentially you could this idea of 51% of the token holders coming together and stealing everything, like it's not impossible, right?
Where does the scaling of Polygon come from? Like, why is it able to process much more transactions than the Ethereum main chain? What's the idea there?
I think in part, I imagine, I'm not sure exactly what its capacity level is, but like I imagine it has a higher capacity because it's a bit more willing to take centralization trade-offs. And then another thing is that, like, if the Ethereum ecosystem, like, even if it did not do that, right? If you think about an Ethereum ecosystem hypothetically scaling with sidechains, then, you would have 100 copies of Polygon. And, they would each have their own tokens, they would each have their own chains. And so even if each one of those chains was only as scalable as Ethereum, you could still, like, the total sum of them would still be 100 times more than Ethereum.
Okay.
The thing that I want to say in Polygon's favor, just to be very fair to them, like, I really, I definitely really, respect the work that they're doing. Yes. So, start with a bit with that word of not criticism, caution, right? Like, it's that they made this kind of deliberate trade-off for very pragmatic reasons, which is that the Ethereum ecosystem needs to scale now. And there are applications that want to do something now. And, if there aren't Ethereum-friendly options for them, then, like, they're not going to just wait peacefully and do nothing for 12 months. They're going to go to, either Binance Smart Chain or, one of some other system, or potentially something that just has totally no alignment with Ethereum values whatsoever. But whereas, with Polygon, like, the best thing that you can say in Polygon's favor and against optimism is that, optimism is not live and Polygon is live, right? Like, it just takes more work to create a system that has these extra roll-up security features. And so Polygon just said, we're going to be the system that makes a pragmatic trade-off. We're going to go, functionality first, and then, we can talk about adding back the security later. So I've talked to them, and, like, in principle, I think they're very, open to the idea of, like, adding more security and like becoming a roll-up, or at least, adding a Polygon chain that's a roll-up at some point in the future, which is definitely something I think they absolutely should follow through on. But, like, the fact that, like, they exist now, and so, applications can kind of bootstrap now on a chain that, even though its security isn't perfect, at least it exists and people can go use it. And then over time, the chain matures as the applications mature. Like, it's, I think, a very reasonable strategy, and I'm definitely, really happy that they're part of the ecosystem.
Yeah, it's kind of interesting. The history of cryptocurrency has this tension of really good ideas that are hard to implement, so they take longer to implement, and ideas that are not as good but are faster to implement. This is like the story of, like, you have, like, JavaScript that basically took over the world because it was quick to implement within 10 days, and then, like, later kept fixing itself. I don't know what to make of that. Sort of from an engineering perspective, I'm more and more becoming comfortable and accepting the fact that our whole world will run a technology that's not as good as it could have been, just because the crappy solution is faster to implement and it sticks. What do you make of that tension?
I think the compromise that we've been taking within Ethereum is, like, when we have to take the crappy solution, we look for crappy solutions that are forward compatible with becoming good over time. Right? Like, when you build the quick and dirty thing, like, you would still already have ideas in your head about, what the more complete thing with all the security features added on would look like, right?
Even if it requires a hard fork?
Yes. Like even so, like for example, with sharding, right? Like I think it's likely that the first version of sharding that comes out, like, is not going to have, ZK snarks and data availability sampling, for example. But we know what these technologies are. We feel like we, have wrapped our heads around them, and so we know how to build a system where we can put all the pieces in place so that it becomes very easy to bolt those components on in the future. So like if you do things that way, right, then at the beginning you can have your system that has the functionality, but say has less security or like less sustainability or less of something else. But then over time, like it's designed in such a way that it has this easy on ramp to adding those things, right? And if you don't think explicitly about like being future compatible, then you do often end up with a quick and dirty solution that backs you into a corner. And I mean, there are definitely cases where, like, I think the Ethereum ecosystem has suffered from that, and we have had to like expend pretty significant effort on, for example, removing features that we didn't realize that we actually can't sustain. Right. Like one big example is just increasing the gas costs. So like making some operations more expensive when they because they should be expensive because they actually take a lot of time to process. Right. So that's making like some things more expensive, kind of like taking some functionality away. So if you can like be cognizant of where you're likely going into the future, and if you don't know, like even be cognizant of both the most likely paths that you'll take in the future, and thinking about your roadmap and coming up with a roadmap where that like if you wants to do either of those things, then you have a clean path toward it. Like, that's probably the best kind of practical way to get the best of both worlds that we have.
Okay, let's talk about this wonderful process of merging. Okay, so there's the main net, which is the Ethereum 1.0 chain, or what should we say? The chain that uses proof of work as the consensus mechanism. And then there's what is it called? The beacon chain that uses the proof of stake mechanism. And I believe the beacon has been deployed successfully, is working. Mm-hmm. So that was in December 2020. Mm-hmm. There's a bunch of questions around that that's fascinating as well. But I think the most fascinating question is about merging those two. When do the two chains, one that's proof of work, one that's proof of stake, merge? Mm-hmm. And what are the most difficult parts of this process?
Mm-hmm. Right. So as you've said, right, the way that we have set up this proof of stake transition is that at first, the proof of stake chain just launches on its own, right? And this is the thing that happened in December. And the proof of stake chain has been running for close to 6 months now. I mean, by the time people watch this, it might actually be 6 months. Mm-hmm. But it isn't actually coming to consensus on anything except for itself, right? Mm-hmm. So the idea behind that is to just give the proof of stake chain time to mature, time for people to build the ecosystem around it, time to make sure that there aren't any bugs, and just like prove to the community that proof of stake actually is real, and it's and a full transition is realistic because the thing that you're transitioning to already exists and already works. Mm-hmm. And then at some point in the future, you have this event called the merge, where you basically take the activity that's being done inside of the proof of work chain and you actually move it over into the proof of stake chain, so you get rid of the proof of work side completely. So the way that the merge will work is it's definitely gone through a few different iterations. Like the earlier versions of this actually required more work for users and more work for clients. It was much more like, oh, there's this new chain, there's this old chain, and then everyone has to like migrate from the old chain to the new chain, and then at some point we'll forget about the old chain. The new version is designed to be much more seamless for users. Right. So basically what actually happens is that the old chain basically becomes embedded inside the new chain. Right. So starting from the merge transition block, every proof of stake chain block is going to contain a block of the what we consider to be the Ethereum chain today, but we'll call it the execution chain. And then at the same time, to create one of these blocks, you're not going to need proof of work anymore, right? So basically, at the same time, you would both get rid of the proof of work requirements for one of these blocks to be valid, but instead you require these blocks to be embedded inside of the proof of stake blocks, right? So you basically have like a chain inside a chain. And this is, from an architecture perspective, it's, you might think it's a little bit suboptimal, but it actually has some nice properties. It makes it easier to kind of think about the consensus and think about what we call the execution layer, like transactions and contracts kind of separately and upgrade them separately. And it also just means that the upgrade process is extremely seamless, right? Because from the point of view of a client that's following the chain, you basically have to update nothing, right? You're still following the same chain and follows the same rules, except instead of checking proof of work, you'll switch to checking that these blocks are embedded inside of blocks of the proof of stake chain.
Got it. So there'll be this merge block that will mark this transition.
Yeah.
And over time, I guess the new chain will contain the full record of all the transactions that's ever happened on the previous chain, on the old chain. So like maybe I'm asking a dumb question here, but in this process, is the new chain going to have all the information of the past transactions?
The new chain is not going to hold information from what happened in the Ethereum chain before the merge, right? So like Ethereum clients of that people are going to use like around the time of the merge and soon after the merge, they're probably just going to sync and check the proof of work chain up to the merge, and then they're going to check the proof of stake chain. But at some point in the future, I think people will just stop bothering checking the proof of work before the merge.
Got it. So that old history information is not important for the future. Like if you're operating actively on the new chain, that history is not important to you.
It's not important. Let's see. So it's not strictly important for just like in any like smart contract or just like applications that run on the blockchain. It can be important to users and it can be important for some applications, but we're basically saying that like maintaining and serving that is not going to be simultaneously the responsibility of every Ethereum node. If you want that information, there can be separate protocols for backing it up. And like these other protocols actually exist, right? Like there's something called the Graph, which is doing some history retrieval. Potentially, you can just take that entire chain and stake it on BitTorrent. Like there's lots of ways to like archive it and create kind of customized search protocols for it.
So what's your sense why... so there's a Python 2 and Python 3, and it took forever for people to switch. What's your sense why this merge has been taking longer than perhaps was expected?
I think the biggest reason is just we've been underestimating the technical complexity. There's a lot of technical complexity in making a successful proof of stake chain. There's a lot of technical complexity in actually figuring out the transition process.
So that's bigger than social complexity. So it's the technical complexity, you would say, is the bigger reason for any delays than the social complexity.
I actually think so. I think we've been very fortunate to not have too much social complexity around the merge.
So not much drama.
No. I think the biggest part of the reason is just because we have been talking about proof of stake and sharding as being part of the roadmap since almost the very beginning of the project, right? Yes. Like the very first proof of stake blog post is from January 2014, which was 2 months after the project started and like maybe even a day after the announcement. So it was proof of stake was not something that we kind of put on anybody by surprise. And then when the DAO fork happened and the people on the ETC side split off, I think it also just happens that a lot of the people that were not willing to stomach the DAO fork and then join the ETC side, they were the more Bitcoiny types, and the more Bitcoiny types do also tends to like proof of work more. And so like that also sort of ended up, sort of like purifying the communities on both sides, I guess. So Ethereum Classic is not switching to proof of stake, and they're happy with their setup. And by the time that it came to the Beacon chain launching, and now I think the community is very strongly in favor of the proof of stake switch.
But let me ask the question that no engineer wants to hear, which is the question of timeline. When do you think the merge will happen? Do you have a sense it might happen this year? Do you have a sense it might be pushed towards next year, 2022, or even beyond?
I think early 2022 is like the most realistic. There's definitely still like an optimistic case of it happening this year, but like the realistic thing to count on is definitely the early part of very early part of next year.
Is there specific things that stand out to you that are like they'll make you feel good about progress if you see it happening?
So the thing that we had last month is we had this online hackathon called Rayonism, where basically a bunch of the different client developers that are going to be part of the transition like hacked together some test nets of the post-merge Ethereum chain. So these were only test nets of what would happen after the merge. They were not test nets of the transition itself. So the thing that people are working on now actually is the transition. So having a full specification of both the transition and post-transition. I mean, we have specifications now, but like, realistically, they'll probably needs to have a couple of changes and have things that continue to be ironed out, and then have a test net that does both the transition and the post-transition. And then, like, once you have a test network, then you just have to do a lot of testing and audit it, and then do some runs on not just a specialized test network, but on, say, an existing test network like Ropsten or Rinkeby that Ethereum people already significantly use. And if it works, then you can deploy the transition on mainnet.
Just as a quick comment, because this is fascinating, in August of last year, there was this Madala.
I believe it's pronounced Medasha. It's a South American subway station. I forget where.
But spelled with two L's.
Yeah, because that's how Spanish works, right? Like the two L's have
Medasha.
Yeah.
Okay, cool. Anyway, but I read about it in middle of August 14th. There was an incident on that testnet. How does this process work? Like, what do you learn from those kinds of incidents when stuff goes wrong in the test process?
I think that incident was that there was a consensus failure of some kind, as I remember. Basically just different clients interpreting things in different ways, and then one of them getting kicked off the network. And then it had ended up taking a while to actually like get everyone to get back online. Like a big part of the reason why it took weeks to resolve, right, is because it's on a test network, like the coins are valueless. And so there's not really this big push of any kind for people to actually, go and download a new client